Welcome. In this video, I'll be covering stoichiometry and the related subjects of moles and molar mass, which is needed to solve stoichiometry problems. Let's start by looking at moles. Moles is a measurement of how many molecules of a substance you have. For example, if you have 1 mole of water, you have roughly 6.02 times 10 to the power 23 water molecules, and this is true for all other molecules. So similarly, if you have 2 moles of air, you will have roughly 2 times 6.02 times 10 to the power of 23 air molecules. This number, 6.02 times 10 to the power of 23, is known as Avogadro's number or Avogadro's constant. And the full number is actually 6.022140076 times 10 to the power of 23, with the unit being 1 divided by moles. So it goes out if you ever multiply it with moles to get exactly how many molecules you have. Another thing to note regarding moles are if you have a reaction equation and you know how many moles you have of one substance, then you can figure out how many moles you have of all the other substances in the reaction equations. For example, if we wish to burn 1 mole of methane, that is CH4, then we can look at the reaction of CH4 plus 2O2 becomes CO2 and 2H2O. By looking at the coefficients, we can see that it would take twice as much oxygen to burn methane as we have methane, and we can therefore conclude that if we wish to burn 1 mole of methane, we would need 2 moles of O2. Likewise, we can also, by looking at the coefficients of the products, determine that burning 1 mole of methane produces 1 mole of CO2 and 2 moles of H2O. Moles are represented by an N in the equation and have the unit mole. The next concept we'll look at is molar mass. Molar mass means how much 1 mole of something weighs. For example, 1 mole of carbon weighs 12.011 grams. The way we figured this out is to look at carbon on a periodic table. Here is what carbon might look like on a periodic table. This specific cutout is from ptable.com, which I'll leave a link to in the description down below. What you want to look for is the atom weight, or sometimes referred to as the relative atom weight. In this case, it's the number situated in the bottom left. However, this may vary from table to table. This number, the atomic weight, sometimes has the unit U. However, we can also, for all practical purposes, say it has the unit of grams per mole, and thereby find the molar mass for a given atom. The next step, and what you'll most likely be using molar mass for, is finding the molar mass of different substances, typically consisting of multiple atoms. The way you do this is you take all the molar masses from the atom in a substance and add them together. For example, you would find the molar mass for alcohol or ethanol by firstly counting the atoms in the molecule, and as we can see from its molecular formula, we have 2 carbon, 6 hydrogen, and 1 oxygen. We then find the molar mass for each atom, which you can see displayed on the screen, and multiply them by the presence in the molecule. So, in order to find the molar mass for ethanol, we'll say 2 times 12.011 grams per moles plus, because we remember we have to take the sum of all the atoms in the molecule, 6 times 1.008 grams per moles plus 1 times, however we'll not include that as it's obsolete, 15.999 grams per moles. We then get a molar mass for ethanol of 46.069 grams per moles. And if you haven't guessed by now, the symbol to represent molar mass is big M, and it has the units gram per moles. The last part of stoichiometry you'll need before we're kind of done is that the small m means mass, and has the unit of grams but can also have the unit of kilograms and so on. In terms of formulas, there are 3 you'll need to know. Moles equal mass divided by molar mass. This is used when you know the molar mass and the weight of substance and need to find the amount of moles you have. The second formula you'll need to know is mass equals moles times molar mass. This formula is used when you know how many moles of substance you have and the molar mass of the substance, and you need to find the weight. And last one, which you'll probably never use, is molar mass equals mass divided by moles. These three formulas can be made into an easy to remember triangle. This triangle, with m at the top and molar mass and moles at the bottom, is used when you need to find one of the three things: moles, mass, or molar mass. And you do this by copying the one information that you don't know, and then the formula simply just reveals itself. Let's look at an example. If we copy the n, i.e. moles, we can see that we need to divide mass with molar mass, which is seen in this formula. Likewise, if we cover the m, or mass, we can see that we need to multiply moles and molar mass, this formula. That's all for today. Please be aware that if you want to see me solving problems you'll face when working with stoichiometry, then the video can be found in the icard in the top right corner and down in the description below. Also, if you're working with stoichiometry in a solution, then I recommend watching the video on solutions, which can also be found in the icard in the top right corner. And as always, feel free to like and subscribe, feedback, questions or suggestions down in the comments below, and as always, have a nice day and good luck with your work.